In order to move my spectroscope slits apart, I need to be able to make a very fine adjustment of them. I'm looking for sort of 1 or 2 micron adjustments in the separation. So I need a very, very fine adjustment, and so I've decided to experiment with differential screws, which is something you find in high-end micrometers and the like. The principle is really quite simple. You can see an illustration of it here. You have a shaft. One side of the shaft is threaded with one pitch of thread, and the other is threaded with a slightly different pitch of thread. And what happens is that when you turn it, what will happen is that these 2 items here will move, rather than move the full pitch of these, they'll move the difference between the 2 pitches. So by making the pitches very close together, you have a very, very fine movement, because it's only the difference between the 2 threads that cause the movement. So if I play this, you'll get the idea. Both of them are threaded in the same direction, so in this case they're right hand threaded, but you're moving the thread, you've got a lot of adjustment but a very, very fine movement, and this should work well. So let's go and have a go at manufacturing it. Okay, so black book. If we look down here, we've got let's have a look. M4 is pitch 0.7, M5 is pitch 0.8. So the difference between 0.7 and 0.8 is going to be 1.1 millimeter, or 100 microns. So divide the 100 by 360, 400-ish. It's about a little over sort of nearly half a micron per degree. So that should give us the sort of resolution we need. So what we need to do is work out is turn a shaft which is going to be half M3 and half M4 and half M5, and so we need M4, a shaft which is M4 and also M5, and then we can do some experimentation and see how that works out. Right, so we're just going to place this bar off. To go up a bit, it's a bit low. Just clean it up on the side. And then because it's going to be an adjustment knob, I'm going to put a nail on it. Stick a nailing tool on there, into place. With a fairly coarse set of nails on there at the moment, but it should be okay. I'll just get that straight. That's about right. Right, just get that down to size. As I say, it's a bit of a so I'm just going to tighten it up a bit more and try again. I'm not particularly bothered if it doesn't come out well, it's only an experimental piece, so I'm going to try and force it in at there. Let's see if we get some oil out of it. Oh, that's a bit better. There we go. That's there we go. I don't know if you can see that, but that looks okay. We've only got to have a 6mm wide. It's just something so you can hold on to it when you adjusting the screw. So that's the knurl. And what I'll probably do is just quickly chamfer that end. And okay, put it speed back up again. Oh, I think 800 is probably about right for that on brass. It looks terribly high. It is terribly high. I don't know why it's quite so high. I don't know what I've been doing with it. That's a bit more like. Just lock it off there. Just takes that off there. That's fine. No rough edges or anything. So what I'm going to do now is just I'll just what am I going to do now? We need it to be 26mm long, so I think I'll just go and saw that off, 26mm, and I'll be right back. Let's try again. Okay, let's face this off. Let's see, we're going to be 4mm on the end there, so we need a fairly small centre. Okay. I would put some jaw covers in there, but because I'm only just doing this as a sort of basic prototype, I'm just it doesn't matter if it's got some ice marks and some jaw marks on it. Right, so let's get that to there, and oops, yeah, there we go. That's it supported. So should run fairly true now. That's absolutely fine. That's going to be supported well enough to do some turning on it. Let's see if the tool fits in around the back of there. Hopefully. So I've got the tool in that will actually reach. So I'm just going to clean it up first, and then I'll mark off the where I'm actually going. So right, here we go. So I'm just going to take it to where that nail is. basically this is going down to 5 mil, so let's put a decent cut on. Indicator on the carriage so that I can see when I'm in the right position. Okay, so let's just see where I am on there. Right, that's 8 mil, so I've got 3 mil to come off. My blades in Imperial, it's easier to do things in Imperial because the dials work better. So we're at 249, so I need at least, so I'm going to take 40 thou off the diameter, which is 40 thou is, I can't quite get in there actually, so not really in that position, so that's 40 thou there, so let's give that a turn. Should take us close. That's 213. I want to be 196, so that's 13 and 4, 17 thou. So if I do 15 thou from there, let's see if I can get it. I might have to just move my. Can't quite get it. I'm just going to have to. Attention, probe into the knob. Anyway, never mind. That's 198. So, hang on a minute, is it 198.195? It says there. Let's micrometer time. Hang on. Oops. 195, so that's fine. That's we'll just out of interest, we'll see what that is in millimeters. That's for the measure. That's 4.98 millimeters, so 0.02, sort of a thou under. that's 4.3 or 169, then I need 157. So if I took 10 off, that would be 59. So take about, I'm going to take 12 if I can. 10. To do, just take that out so I can that's 158, or a bit, just slightly over. That's 4.029, so 158. I just need probably just a thou, probably just a spring cut really. That's still one, a little bit more on the old file. I'll do 4mm. Right, I've just got to tap it now. Let's just keep that straight just in case. I only tighten these with my fingers and really probably need to get it grunked on properly. That's working now, so I'm going to back that out so I can see what's going on. Looks like we're turning a reasonable straight thread, which is always good. Now, doesn't get us to the end, it gets us nearly there, and that's all that's going to matter. So that's the M5. So now what we need to do is change for the M4 and do the front bit M4. So I'll get it started on this now. I'm going to swap it around so that it's got the flat side, as it were. Right, so that's up against. Looks like we're going. Whoop. What's happening there? It wants to go on the piss. I think we're cutting now. Oh, there we go. Well, this is going right up to the end, so we should be alright there. For the purpose of the experiment, I'm sure that's going to be absolutely fine. So that looks like we have an M4 and an M5 thread. I'm just going to... Hi, so what I do need is this is the beryllium copper and what I'd need is a 22mm strip here, which is what I'm then going to cut the actual these parts from. I've got a bit of a prototype here, I think you might have seen it before. It's a bit rough, but so I'm cutting a 22mm strip, of which I'm then going to cut 4 of those out, so I'm going to actually need 2. Now I need to do these as accurate as possible, because in order to get these holes in the right place, I'm going to have to fit them into a jig, which I'm then going to have to make. So what I'm going to do is cut the pieces first and carefully measure them, make sure they're all within tolerance, and then make a jig to fit the piece, which then I can use to punch the holes so that they're in exactly the right places. Now I'm going to be using this guillotine here, and if I get one of these little pieces of there's some scrap stock over here, you'll see that this guillotine actually makes quite a nice job. This isn't a particularly good bit that I've got here, but you'll see that it actually cuts a nice cut. So it's perfect for doing this. I was using tin snips before, but then I realised that you can't really get accurate square with tin snips, whereas this, I've just cut this piece and you can see here that's perfectly square there. Now, in order to get the 22mm, I really need a stop to make it repeatable, because I'm going to make, say, 3 pieces of these just to make sure. So what I've done is I've clamped, you might be able to just see here, I've clamped the guillotine here to my surface plate, and then I've used this angle plate, which is pretty heavy and it's not going to move. I'm going to be very careful and light with it. So up against there, hold it down flat, and let's have another one. Hold it down flat, watch my finger ends. Slightly dangerous guillotine, as you can see. I don't think you can get these anymore. I bought this at the Auto Jumble. It's a really nice little guillotine actually, but completely illegal, I'm sure, in schools and anywhere really. Right, okay, I'm going to move that out of the way, because that. So here's my 3 pieces. They all look. What you see here is a punch. It's got, if I bring you around here and you have a look, it's got this, there's a die at the bottom there. If I just pull this down, you'll see that that goes into the die, and the punch itself is in here. I've got a full set of tools that go into this punch, so that you can punch all sorts, a whole manner of things, from holes to connectors for panels, and there's a ton of accessories that are with it. But this is I think it's just over 3mm hole, which is what I need. But I've had to make this jig to allow me to punch the right holes. Now this is my sort of prototype, so actually it's the wrong way around. That goes in there like that, because the dimensions of this are ever so slightly different from the from this prototype you want. What I've done is I've just adjusted these until they're right and they fit, which is more important than anything. So I'm just going to, with this jig, which has taken me quite a while to set up. It's fairly typical of this sort of job. It takes you 2 hours to set the work up, and then it'll be 5 minutes just punching, not even that, punching the 16 holes, because there's 4 of these plates and 4 holes in each plate. So I just go punch, switch it over, punch, and that's it on all of them, and hopefully they'll fit. So I think I might just do a test one first, just to be sure. So let's go and do that first. Okay, here goes nothing. So that goes into there, into that corner. Pull the bar across and punch. There we go. You've got to be careful. It seems to be quite susceptible to splitting, this beryllium. It's so yeah, that's absolutely fine. So all I need to do now is turn that one over and do it that way. And pop, there we go. I've got to be careful of taking it off the hole so that we don't damage the hole. So that looks pretty good to me. And then flip it over that way and repeat that. So it's that hole there. I've got the depth stops set so that it doesn't barge through. That's the last thing you want to happen, is it first, because it just splays the hole, because this is tapered, this die. So you basically just want it to nip through like that. Now that looks okay to me, so I'm going to go and do a quick test of it and see what happens. Well, that's one side in. Alright, just screwing this last clamp on the inner carriage. Okay. What I hadn't thought about is that, you'll see when I've done it, let me just clamp this on, is that this side here, I don't know if you can see there's a step there, but I had to relieve this because the other spectroscope slit, sorry, the blade, which is meeting, the one on this side is clamped to this piece itself, the one on that side is clamped to the outer carriage, but I didn't want it to rub on there, so I've basically relieved that by, I don't know what I did 10,000, something like that, 15,000. But as a result, you'll see now that the spring sticks up there. So what I might have to do is just make sure this is nice and well accurately seated in here, and then trim off that bit there. Either, I don't know, I'll either mill it off. If I clamp it and mill it, might work, or just shear it. I might, I'll see what I figure. I might have to remake these blades anyway, because I'm not entirely sure there's enough springiness in them. Now I'm not terribly sure how well this is going to come out, but let me just point out a few things that are going on here. Right, so I've got the whole thing attached to the housing, and I've got it clamped down onto my mini pallet just because I want to be able to hold it steady. And this is the inner carriage, and that's the outer carriage. And I haven't got the slip blades on yet, but so what I'm doing is, with regards to this, I am measuring the inner carriage with this indicator. Unfortunately, I can't get my comparator in there because my lever head for my comparator is cream crackered. So I've only got a plunger style, and I can't get the plunger in there. I suppose I could have got it across there onto there, but anyway, I'm doing it with this at the moment. So this is a 0.01 millimeter per division. So each one of those divisions is 10 microns. 100 microns is where that 10 is there. So each division is 10 microns. So what I'm actually measuring is the movement of this one blade in regards to the stationary bit, which is here. Now remember that both of these elements move the same amount in opposite directions, which means that I'm reading double on here what the actual movement of the blades, the separation of the blades, will actually be. The blades themselves will only move half of what one of them will move, because they're moving, hang on, have I got that right? No, I'm measuring half of what they will move, so whatever I read on there, it will be doubled for the separation. But this is the differential screw at this end here, So the differential screw has an M5 at this end and an M4 at the other end, which means that there's a difference of those two thread pitches of 0.1 of a millimetre, which is 100 microns. That means that one full turn of this knob will move that 10 divisions on here. Now I've put this cardboard pointer on there so that you can see what happens when I turn it. Now when I put the screwdriver on, I've got a thing on the end here to turn it. When I put that on, because these are all obviously springs, you do get some movement on there. So what I'm going to do is adjust it very, very slightly, and you'll see the needles change. So if I move it about that much there, that moves. I'll do it again. I'll move another. So that is one division on here. So by moving about quarter of an arc on the screwdriver, I've effectively moved 10 microns. So that there would be 5 microns, and that goes back to where we were. Now the great thing is there's absolutely no backlash, so I can turn it like that, I can turn it back to there, and the needle on here is exactly the same. So if I turn it a little bit further, like down to here, I think the needle will drop off. The needle's not on very well. You can see now I've gone 2 divisions. So that's 2 divisions. Oh, the needle's dropped off. Right, let me put it back to where the 2 divisions were, so we know where we were. Right, so we're there. So if I put that back there, sorry about the needle, guys. So there's 2 divisions. If I go back to about there, it should be back to 0. I've just gone past it actually slightly. There we go. So it's about there. So pretty pleased, pretty successful. It's obviously quite sensitive, and when you touch it, it obviously moves. But you can very precisely set the gap. So if I want to set, if I've got my gap, my blades, the blades when I set them up on here, I'll have them touching at that point. I'll be able to move them apart by 5 microns, 10 microns, 15 microns, 20 microns, and that is pretty cool. So now I've got this test bed. I'm going to continue manufacturing the blades, and hopefully be able to strap this to a light source and measure the spectra coming through the slits and see the quality of the slits. Now the other thing I'm going to do, and I might do that on the next video, but I'm going to use once I get the slit, I've got to get the slit blades done to do that, but once the slit blades are on, we can then calibrate the distance on here using a laser and interferometry. So I shall make sure that I'll do a video on that, because I'm sure a lot of you will find that very interesting. But it's a way of setting very, very small distances, and it's actually a very, very simple technique, and allows you to set distances to an accuracy of 1 micron very easily. So I should be able to calibrate this now. I might have something better than this cardboard finger, to be honest, but for the purpose of what I'm trying to show you here, the cardboard finger works just fine. So hopefully you found that interesting, and my lash up interesting in its own right, but it works. I'm pretty pleased.